if you're wondering if you're in the right session, this title has slightly transformed since I submitted the talk back in March, but I'm largely going to cover most of the same topics. There we go. So my name's Kerry Steele. I'm a principal consultant. Sorry. My name's Kerry Steele. I'm a principal consultant at Coalfire and the compliance advisory practice. I've been a QSA since 2007, so I've been working with PCI DSS since version 1.1 when it was a whopping 17 pages. In my role at Coalfire, I provide compliance advisory services around PCI DSS compliance to business and technical leaders. And I'm frequently engaged on projects to either define or reduce scope. Over the last year, I participated in development of the recently released Scoping and Segmentation for Modern Network Architectures that was published on Monday. And I engaged some of Coalfire's customers. They might be in the room here, John and Ricky. Yep. So the team at Equifax, we worked with the team at Equifax to contribute some of the guidance that we have co-developed for the Equifax developer team and engineering teams since 2019. So some of the real-world scenarios and implementation criteria that exist in the section 9.2 of the latest guide. Thanks to the Equifax and Coalfire team for participating and contributing that to the guidance. So in this session, we're going to talk about micro-segmentation, identity-based micro-segmentation, and some practical strategies for implementation to reduce scope. So our threat landscape is constantly evolving. Attacks are becoming more sophisticated. Attackers are becoming more persistent. So consider a few examples. Snowflake, SolarWinds, I want to say CrowdStrike, national public data, ransomware, open source libraries, software libraries, AI deepfakes are all new threats that we're facing in the modern landscape, today's landscape. I asked AI to generate an image of a castle in a medieval town with a moat, surrounded by a moat, and I kind of think the AI knew what I was getting at, because to me this looks a lot more like a target with the houses being poised, ready for attack. And that side door down in the bottom left, what is that for? Maybe 24/7 access for a contractor? So traditional perimeter-based security models that solely rely on implicit trust within the boundary are really no longer these days adequate. Zero trust and many of the modern network security controls address this challenge by eliminating implicit trust with a data-centric approach that verifies every access, all access, and every request. So according to CISA Zero Trust Maturity Model, Zero Trust is implemented across 5 distinct pillars. So with identity, you have any attribute or set of attributes that uniquely identify a user or an entity. You have devices, which refer to any hardware device that can connect to a network. We have networks, which are any open communication medium, which could be the internet, an internal network, a wireless network. Applications and workloads refers to any computer program or service software code that's running either on-prem or in the cloud. And data is any information that's critical to running a business. The model also includes visibility and analytics, automation and orchestration, and governance that for integration of within the pillar and across the model. So as you can see from this diagram on the right, the journey to zero trust adoption is absolutely a journey. Allowing organizations time to implement, plan and implement zero trust. In the traditional phase, we have least privilege that's assigned at provisioning. In the initial phase, we're starting to automate some of the least privilege assignment. In the advanced stage of maturity, starting to assign least privilege based upon risk and posture of the user or device. And in the optimal stage, there's just-in-time access, just-in-time, just enough access, dynamically delivered for every access request. So what does this have to do with PCI DSS? Zero trust, as I mentioned, is a data-centric approach that is meant to verify every access request. Zero trust this is performed with identity-aware micro-perimeters that minimize lateral movement and unauthorized access. What's interesting is you take a look at the transformation. So I've omitted the initial and advanced phases for purpose of readability. But if you look in the network column, you can see the transition from large perimeter-based, macro-based segmentation to micro-segmentation with micro-perimeters that provide just-in-time and just enough access. And you can see in the identity where, I can barely see it, so where access is provisioned, where least privilege is assigned at provisioning to the transition where access is dynamically provisioned. In the applications and workloads, you can see that there's a progression to immutable workloads with security testing throughout the life cycle. So I got a little bit ahead of myself. So what does this have to do with PCI DSS 4? Well, actually, PCI DSS rather, has really been aligned, zero trust has been aligned with PCI DSS since the beginning, with concepts like least privilege, denied by default. And with PCI DSS 4, new requirements have been introduced for requirements 839 and 831.1, which provide the option for dynamic authorization. So limiting PCI scope can provide a significant cost savings as it relates to implementation, maintaining, and assessing controls. I can barely spin this. And what I'm going to describe is how micro-segmentation with service mesh can enforce a zero trust environment or zero trust posture for payment workloads. And in doing so, reduces risk, it can reduce scope, and enhance security posture for payment systems. So consider this example. With traditional network segmentation methods and traditional networking, all of these systems might be considered in scope because they're connected to the in-scope components. Now, in this case, IST.io is the service mesh with the control plane that acts as the network security control to isolate and de-scope these non-payment related services. So service mesh is one of the modern network security controls that's covered in the updated guidance. Service mesh is critical to modern microservices architecture. Provides the infrastructure for secure service communication. It enables mutual TLS or MTLS to authenticate both sides of a conversation, client and server, and encrypt traffic between services. So in addition to MTLS, it provides the ability for fine-grained authorization policies, so you can control or limit access at the service level. In identity-based micro-segmentation leverages what's called workload identities. These workload identities are leveraged for dynamic policy enforcement between services. So what are workload identities? Workload identities are workload identities are assigned for the purpose of identity-based segmentation, and the way that this workload identities are issued to services with what's called SPIFFE, the Secure Production Identity Framework for Everyone. The workload identities are carried in what's called SVIDs, or SPIFFE verifiable identity documents, that enable authentication of services between services regardless of the underlying infrastructure or platform. So these SPIFFE and SVIDs can literally be assigned to any piece of code that's running on the data center or on-prem or in the cloud. And so these workload identities are issued by workload identities are issued per service. So each service would be issued a SPIFFE-based ID. Now, in microservices architecture, these workload identities are issued to what are called envoy proxies. These envoy proxies are referred to as sidecar proxies in that they are running alongside each microservice. So Envoy is a layer 7 proxy, a lightweight proxy. Again, it can be implemented to run alongside each service in a microservices architecture. It can also be, Envoy is also leveraged in a service mesh architecture as a gateway in ingress and egress to the network. So IST.io is an open source service mesh that provides authorization, authentication, and secure naming for workloads. So the IST.io is the policy administration point that provides policy for each of these Envoy proxies. And as you can see in the diagram, there's a proxy running alongside each service, as well as an Envoy but in both ingress and egress paths through the network. So IST.io authentication policy controls the workload identity or workload authentication modes, the MTLS authentication modes between services. I pointed it out here because it's interesting. You know, any control that you implement, you have to understand how it's implemented, how it's secured, how it's configured. So, you know, even with IST.io, out of the box, it's configured with a permissive authentication policy that allows unauthenticated access, which something that you might not want in a payment system or payment environment. And so it's recommended to turn on strict authentication. In reality, many of these things might be configured by a cloud service provider as part of a managed service. which would be defined as part of the shared security responsibility model for the service or provider. In addition, leveraging the customer compliance guides that service providers provide for configuring and securing services should be leveraged as well. So SIO authorization policies are similar to authentication policies. They're defined in infrastructure as code. They define the policy that's implemented on Envoy proxies for the Envoy proxies to become the policy enforcement point, very similar to a traditional firewall. So these infrastructure as code rule bases, they could become in scope for, certainly for a payment environment. And these Envoy proxies, again, they have an authorization engine that runs at runtime that verifies and authenticates and authorizes each request. So in conclusion, service mesh and other modern network security controls that can enforce the zero trust posture they're well suited for the payment environment. And adoption of zero trust and these modern controls, it's certainly going to be a path to adoption. But leveraging, implementing micro-segmentation and an identity-based micro-segmentation for microservices in a payment system during the initial phase of adoption, the benefits can be quite significant. And by adopting these technologies, service mesh, identity-based micro-segmentation, workload identities, zero trust architecture, implementing zero trust architecture via ISSAP and Envoy proxies can not only reduce scope, can certainly enhance security posture and reduce risk of payment environments. And that's a few references. So I mentioned the scoping and segmentation guidance. Certainly, we provided, in the guidance, there's a number of real-world scenarios, and certainly leverage some of these resources to learn more about implementing zero trust, implementing microservices, leveraging a zero trust posture for implementation of these modern network security controls. So thank you.